Alright, this should be a pretty short video. We're going to talk about something called radical expressions. Okay, so a radical expression is anytime you see this symbol. Okay, so some of you might know that as square root symbol. But it's not always going to be a square root. Right? A square, remember, is two-dimensional, right? We have a y-axis and an x-axis, right? So we have a depth and width, or width and length, however you want to say it. So square, right? But we can also have cubic, right, where it's three-dimensional. Right? So this would be the z-axis. Imagine that coming out of the screen, right? So we can also have three dimensions. So in which case we would put a 3 in what is called the principal root. This is called the index or principal root, right? So we have an index of 3 here. So now it's a cubic root, right? So if I said cubic root of 8, what I'm asking is, this is just an example, a cubic root of 8 would say what number multiplied by itself the index number of times, and the index here is 3, right, will give us the value of 8. That's all we're asking. Very simple, nothing to overcomplicate. Well, and the answer we can see is 2, because 2 times 2 times 2, right? Right? So we can see that the cubic root of 8 is 2. Now, if there's no number written in this index spot right here, we assume a 2, and that is a square root. So if I said the square root of 4, again, we have a value of 2 because 2 can be multiplied against itself twice to get 4. Okay, so a radical is an expression of the form that you see right here where you have the nth radical root of a. Okay, and what that means is that the positive integer n, right, and positive integer just means a positive number, something 1 or greater, right? So we're not dealing with negative numbers here. So the positive integer n is the index, root, or order of the radical, where the radicand is a here, the pink a. That represents the radicand. The blue n represents the index, order, or root of the radical, and the radical is this green symbol right here. And again, where the n is, if the index is omitted, we assume a 2. Okay? So that's what's going on with radical expressions. An example that might help us understand the relation between radicals and exponents might be if we think back to exponents of rational exponents, so fractional exponents. So if we think back to fractional exponents, we could say a, some number, taken to the power of 1 over n, we say is the nth root of a, right? So if we said a to the power of 2 over n, that would equal the nth root of a squared, so on and so forth. So we can see the relation because what it tells us is, if the rule of exponent tells us that a taken to a fractional exponent gives us this format, well then the inverse is also true. So if I have this format here, a radical format, I understand that that is equal to this exponential format. Does that make sense, guys? Okay. If you have any questions, just message me in the box below and I can go over this in more detail. Alright, cheers.